Hello guys, how are you? I hope you had a nice day and you're having a nice exam. Again, this is for FBC student Com 1. Before you start, if you haven't subscribed, go up there and subscribe. Thank you very much. I will go a bit fast. We just do a brief summary of the rectangular waveguide for the transverse magnetic. We have seen transverse electric field. Everything was given in class. Now I'll just give you a brief summary of the transverse magnetic. So here this is a rectangular waveguide, as you can see, and this is the length A and B, and always A is greater than B because of course it's rectangular. Here we have the medium, the permeability and the permittivity. When you understand, what do you understand by transverse magnetic field? Transverse magnetic field is characterized by the field with Hz equals 0, and the electric field must satisfy the reduced wave equation. Therefore, Ez must be different of 0 since it's this one which is satisfying the reduced wave equation. So remember, for the transverse electric field, we have the minimum mode was 1, 0, 0, 1, and so on. For the transverse magnetic field, the wave propagate at the minimum mode where m equals n equals 1. So the lowest cutoff frequency for the transverse magnetic field is Fc Mn, where m is 1 and n is 1. Therefore, I will now give you the very important characteristics we need to know about the rectangular waveguide for the transverse magnetic field. We need to know the cutoff frequency, which is the cutoff wave number, which is the same as the transverse electric field. We need to know the wave impedance for the Tm, which is different from the wave impedance of the transverse electric field. We need to know the wavelength, be it guide or cutoff wavelength. Of course, we need to know the phase constant. I will call your attention, we know the attenuation, the propagation constant, it was the attenuation plus the phase constant, which is real, right? And again, where we need to know when we derive the propagation constant beta is k square minus kc square root square. For this to exist, k need to be greater than kc, and for that, beta need to be a real number for this to exist. Therefore, when we have beta, as it was the same with the transverse electric field mode. So what is Kc is uniform. Kc is mp over A plus np over B. Of course, this is square, and this is square here. So this Kc, of course, if we don't have this, then we have root square. So this Kc is uniform for everything, okay? Now, we need to know the very important is the cutoff frequency. What's the cutoff frequency? Fcmn is Kc over 2p root square of the permittivity and the permeability of the medium we are in. We have Kc, you just do the substitution. Then we have the frequency, the cutoff frequency as 1 over 2p. This times the cutoff wave number, which is mp over A square plus np over B square. Of course, this one is greater than this. Never forget that. And here, as we said, the dominant mode, this is the dominant mode here, is m equals n equals 1. So now, what's the wave impedance? The wave impedance here for the cutoff frequency at this level for the transverse magnetic field is different from the wave number of the transverse electric field. For the transverse electric field is kn over beta, while for the magnetic field is beta n over k. So that's where the difference lies, okay? Electric field kn over beta k. Magnetic is beta n over k. So this the wave impedance. So remember, we have the attenuation. What's the attenuation? The attenuation here attenuation due to conductor losses or attenuation due to dielectric losses. The attenuation due to conductor losses is the same, is RS over A. Remember I gave you an assignment about that, and a lot of students were asking me what's the formula of the attenuation due to conductor losses. This is the formula, okay? And due to dielectric, what's the formula due to dielectric? I don't know if I think I've given that in class as well. So due to, it should be K squared tan loss over 2 beta. You have these two, right? So the waveguide cutoff is 2p over kc. The guide waveguide is 2p over beta. I think I didn't forget anything. Are you with me? Let's have it clear. Now Tm is beta n over k, while I told you Ce is kn over beta difference. Okay, I think everything is given here. We have given the cutoff frequency as well. Here I've given it here. So there was a problem given. So to solve that, you need to know these two, which is given. So thank you very much. I'm gonna do another tutorial concerning noise. I will do a brief summary about noise the next tutorial, and just try to solve some problem. No, maybe one problem I didn't do for you. Thank you very much, and don't forget to subscribe. Cheers.